Shipping accounts for a mesmerizing 90% of world trade. With so many containers being moved around the globe, seaports play the most important part in this process. To understand how exactly they work, we must dive into the current system which is in place in most parts of the world. Moorings are used as shown. As a ship approaches, local maritime port assistants help to secure the moors, and tugs help the ship into place. Large ships are tied using moorings. As a ship approaches, these lines, along with local maritimes, assist to dock the ship. Here you can see how big and massive heaving lines are. The actual docking process can take a really long time. Usually, 4 tugs are used to dock. Heaving lines are formed into monkey fists, which are then thrown onto the port. Gantry cranes are used to carry these large containers, and automated vehicles are used to transport them. Containers are carried by fully automated vehicles in some ports. Cranes can be hinged to allow ships to pass through, or fixed.
So what exactly is 5G? 5G is the next generation of telecommunication networks. I'd like to show you a comparison of 4G and 5G. As shown in Figure 1, 5G has a higher packet transmission speed compared to 4G and also has a lower latency when compared to 4G. Since 5G has low latency, real-time monitoring systems are made available, and with the high transmission speed, it can connect many people and even allows us to control machine, objects, and devices. So what are some of the computer network concepts that can be implemented? These are TCP/UDP hybrid, network slicing and redundancy, as well as device-to-device connections. To maximize the potential of 5G, a mixture of both protocols is used to ensure a real-time, low-latency, and reliable connection, and is achieved as it is important in automation. With a UDP-TCP hybrid, devices can offer a fast transmission speed by using UDP while maintaining reliability using the congestion control feature of TCP. The following animation shows how the TCP-UDP hybrid work together. The first step is to establish a connection using the three-way handshake. Once the connection is established between the client and server, the client sends a HTTP request to the server using the hybrid TCP/UDP protocol. The server can then decide whether to use either TCP or UDP. In this scenario, the server selects UDP to respond to the HTTP request. The packet is sent to the client in a much faster speed with lower latency. File transfer between the server and the client uses UDP, which means error checking does not occur. However, to confirm that the packets are received by the client sends acknowledgement packets in a fixed time duration. For example, every 5 seconds. In case of packet loss, the client will send acknowledgement packets to the server, and the server will then use TCP for retransmission and perform a congestion control. Network redundancy and network slicing are used to prevent network congestion in 5G. Network redundancy provides network availability in case the primary path is unavailable. The data can be rerouted to other redundant network links. As a result, the transmission of data will not be disrupted due to network links or component failure. Network slicing enables service providers to build virtual end-to-end networks designed for different application requirements. It ensures level agreements for quality of service are met. The following animation shows how does the network redundancy help prevent network congestion. There are a few physical connections between the sender and the receiver. The transmission of data is represented by the red lines from the sender to the receiver. When one node is physically damaged, the transmission of data will be rerouted to another path in order to get to the receiver. We can see that there are multiple end devices connected to the 5G node, which uses virtual end-to-end networks. 5G can provide device-to-device or D2D communication, which is better than peer-to-peer connection and client-server networks. D2D communication refers to a radio technology that enables devices to communicate directly with each other without the need of routing the data paths through network infrastructures such as cell towers, small cells, base station. The first problem, poor connectivity. Since the port is a place where there are a lot of devices and metal containers, signals sent within ports are prone to noise and EMF distortion. With the increased number of devices also increases the network traffic. As a result, the overall connection speed of the port is slowed down. As an example, the host on the left will send their packets along the 12 megabits per second links to the first router. The first router then directs these packets to the 1.7 megabits per second link. If, during a short interval of time, the arrival rate of the packets of the first router exceeds 1.7 megabits per second, congestion would occur. This is because the queue becomes full. This increases delay and causes packet loss. Therefore, automated processes are impossible due to low connectivity and low bandwidth. Mooring crews communicate with the bridge crew using radio connections, which is unreliable because radio transmission is a single-way transmission and therefore it is prone to distortions. Hence, this can incur delay which can cause inefficient communication. In ports, the nodes are also far apart, which increases the delay of the messages transmitted. Due to the lack of automated processes in ports, tasks such as mooring ships and container moving are done by humans, which is inefficient. This is because they use primitive methods such as forklifting to fetch and arrange containers. In addition, arranging of containers requires supervisors to guide forklift drivers so that they can place the containers in the correct position. Mooring crews are still required to monitor the tension of mooring lines due to the change in tides and waves. This is inefficient as human-initiated processes require more time to complete. Therefore, how can 5G solve the problem stated earlier? To understand how, let's look at the two main benefits that 5G can bring to ports, which is to increase connectivity and bandwidth as well as increasing the efficiency. So let's talk about the first benefit. This is achieved through three main components of 5G. This includes massive MIMO, beamforming, and small cells. Since there are many devices used in ports, an antenna that can handle multiple channels are required. Massive MIMO can come in handy in this case. However, with so many channels broadcasting signals simultaneously, it can cause signal interference. This is where the second component comes in, beamforming. Beamforming helps to prevent interference when there are a lot of signals propagating in the air, as shown in the diagram. What beamforming does is that it allows signals to be directed to one device at a time. Therefore, the signals can propagate to its target directly as shown. Due to the limited range of 5G network signals, it requires the third component, small cells. Sometimes signals cannot reach their destination. With small cells, the signals can easily be relayed successfully throughout the port. Small cells typically have a range of 1 mile. Thus, they are placed strategically to ensure that the signals are distributed equally throughout the port. Through this, all parts of the port are able to access the high bandwidth and low latency 5G connection. The second benefit is that 5G in ports increases the overall efficiency. The low latency and high transmission speed 5G packets allow automated technologies such as automatically guided vehicles and automated gantry cranes to be used. Now, what exactly are these? These two infrastructure components work together to solve the biggest problem in ports, which is inefficiency. Let's discuss about automatically guided vehicles or AGVs. AGVs are a smarter alternative to conventional man-driven forklifts, and just like normal forklifts, AGVs can transport one or more containers at one time. The reason why AGVs should be used is because it can effectively minimize the number of forklift drivers on the port roads and thus reducing the consumption of natural fuel as it is battery operated. There are three main components in AGVs, which are navigation, path decision, and traffic control. For wired navigation, a continuous wire is embedded into the ground, and the wired sensor is placed on the bottom of the AGV facing the ground. The sensors will then detect the radio frequency being transmitted from the wire and follow it. However, the disadvantage is that over time there is a risk of failure due to wear and tear, as wired navigation requires physical cabling. Hence, maintenance is needed, and this is inefficient in terms of cost. In addition, these continuous wires fixed on the ground is not scalable because if new wires are to be added, changing the paths is not easy. Since 5G has high transmission speed and low latency, it can meet these time-critical requirements needed by the AGV. Artificial intelligence and device-to-device or D2D communication can be used in both path decision and traffic control. D2D communication allows AGVs to communicate with each other and exchange information such as destination, path taken, and container content. And based on the following data, AI can help in analyzing the routes taken by each container, thus planning the fastest and safest route for the AGVs to take. AI can also help in detecting collision before it occurs. Therefore, the use of AGVs can significantly improve the time and cost efficiency as well as safety. This is a short clip on how the AGV's AI avoid collisions. As mentioned earlier, AGVs is meant to complement the automated gantry cranes, or AGC in short, to maximize efficiency. As soon as a trailer with the container arrives, the AGCs make use of the cameras and sensors to read the information on the containers and plan the most efficient way to stack the containers before picking it up. This is only made possible with 5G and augmented logical planning. The high bandwidth and low latency of 5G allows video information to be processed and relayed to the central system quickly. Augmented logical planning. This is an algorithm that helps plan how to stack containers in the most efficient way. As the container's information was picked up by the sensors and camera, the AGC relays the information to the control center's computer, which uses augmented logical planning algorithms. The algorithm then stacks the containers based on the departure time. Containers that depart the soonest will be stacked on the top so it can be picked up easily, and without proper planning, more steps are required to remove the particular container if it is buried too deep in the stack. This would not only take more time to do so, it also requires forklifts which run on fuel to operate for a longer time, and this in turn will incur cost inefficiency. Therefore, AGVs and AGCs can significantly improve time and cost efficiency. To wrap up this video, we would just like to recap what we have covered in this video. We have covered what is 5G, what are some of the 5G concepts, what are the common problems in ports, as well as what are the 5G solutions. And that's it for this video, and thank you for watching.